Hey everyone, so I just thought I'll do a little video between sort of a test between Django and FastAPI. If you don't know what FastAPI is, it's basically a micro framework that allows you to build API endpoints. Um, and the whole point of FastAPI is it's asynchronous in the sense that um, a task behind, so you have two tasks, task 1 and task 2. Task 2 doesn't have to wait for task 1 to finish. It can go off and do something else. Because assume task 1 is trying to get some data or something, it doesn't hold up the task behind it. And that's the whole point of asynchronous. So it's very good for sort of real-time applications and things like that. So why this video? Well, I previous to this, I did a test between Django and FastAPI, and all it was doing was returning some JSON, and I couldn't actually see the benefits of it in the sense. So it kind of really intrigued me as to, I wanted to see for myself the benefits of FastAPI, and I understand that it's good for like I/O stuff, so writing to the disk and reading from the disk. So in this video, all I'm really going to be doing, is reading from the disk. So I mean, if you're watching this video, I'm going to assume you know what FastAPI is. So I'm not really going into too much detail here. But if you do want to, just look up FastAPI and look at the docs and stuff. What I like about it, it depends on your use case. So I mean, if you want to build everything from ground up, like you would do with say Flask or something, it's good in that sense. So you got to build your views. You got to do the your base models, your pydantic base models. You've got to do the authentication yourself, the headers yourself. So it's pretty much you got to build from scratch up. But what it gives you is this asynchronous behavior, where the performance is going to be a lot better than Django will. And I'm going to do a test now, and I'll show you. And what I'll do is, instead of me trying to analyze the results, because it can be a bit tricky, because I'm using a package called Locust that allows you to sort of replicate API requests coming into your server, for example, and it can sort of mimic high traffic and things like that. So you can see where your API starts to struggle. So I'll use this for the test. And I just want to show why you would want to use FastAPI. So for context, all I've really done is, I'll show you here. If I go to request.body, because what I wanted to do was have a base model that behaves like a Django serializer, so you then have the data come back out. So in my case, I'll show you here, not here. Let me grab it. Sorry, 1 second. Let me. Go to somewhere. Yeah. So this is an app I was working on, but I'm just using it for now for this SQL test. So all I've got is in the main, I've got this service model. All it's going to do is it's got a code, it's got a name, description, Stripe price ID, and this is basically why I've got that. Is this? It's a schema taken from one of my other apps. I just wanted to do a test on it, but you won't see any Stripe IDs in this and things like that. So nothing to worry about there. All it's going to do, I've already used this to create. I've got a post view that creates the service just so I can then retrieve it. But the test is actually going to run on this service. So all it's going to do is say, give me the first service you find, and that is what you see here. This is coming back from FastAPI. It's running on the same, both endpoints are running on the same kind of EC2 instance, a TG medium. So there's nothing in terms of, it's not like one server it's got more memory or anything like that. It's running on exactly the same server. So there's nothing to worry about there. So that's pretty much it. On the Django side, it's pretty straightforward. Have I got it here? So I've got it here. You can see it's pretty much returning the same thing. And it's, yeah, so it's just returning kind of the same data you see here. So there's no, so it's not like one is returning more JSON than the other. They're both returning the same thing. So anyway, so for my actual test, I'm gonna use Locust, and I'll put it in the description if you've never used Locust before. And let's see what happens. I'm going to just clear this. Oh, by the way, on the Locust side, what I've done on the Locust side, I've created two classes. One is going to go to the FastAPI host, which in this case is just a AWS URL. It's going to go to that endpoint there. This is my app. I'm using my app as a means to make this video, and I'll get rid of all of this later on in the app, but this is going to go to this endpoint and pretty much return the same JSON. So that's the Locust side. So I'm just going to run this now, and what I will do, and I'll show you, I'm going to use ChatGPT just so we can get more of the analysis from that. So I'm going to say hypothetically my peak is 100 users. This is when let's assume it's Django starts struggling or whatever. I'm just going to sort of try and do it. So let's go to the charts, and I'll just keep an eye on my users at the top here as this chart is running. They're both going to two endpoints, but it's not very clear on this chart. So for the time being, just bear with me, and I might actually just pause this video because I don't think you want to watch this. But basically, I will stop this. I'll stop Locust from running as soon as it hits the 100 user mark up here, and I will come back to the data. But anyway, you can see it's chugging away. It's pinging both endpoints at the moment, and I'm just going to pause this. So I have now stopped the request as it hit the 100 mark, and I'm just going to kill it. You can see the stats down here, but instead of trying to work out all of this stuff myself, I'm just going to get GPT to do it. Sorry, I'm a bit lazy. So I am just, bear with me, and I'm going to just get my prompt that I built earlier for this, and I'm going to take this stuff and let GPT analyze it for me. Sorry, I'm being a bit lazy. So let's see what it comes up with. The data provided here. Right, so general observations. So the Django 4,100 requests with no failures. Service, which is the FastAPI one, 23,873 requests, no failures. Both endpoints have 0 failures that I know. Response times. The Django one, average response time is 647 milliseconds with a median of 650 at a max of 23. Service has a significantly lower average response time, 109 with a median of 100 and a max of 427. Request rate. Django handled 39.85 requests per second. Service handled 20. Oh wow, check this out. Sorry, I was about to swear there. Service handled 23.02 requests per. That is freaking nuts. Holy shit! This indicates that FastAPI handled significantly more throughput compared to Django in this test. Performance. The response times for FastAPI are considerably lower than for FastAPI. Medium response 6 milliseconds versus 100 milliseconds for FastAPI. Maximum response times. Django was 2,033 milliseconds for Django, 427 milliseconds for FastAPI. FastAPI supports high request rate, processing nearly 6 times as many requests per second as Django. Wow. Percentile breakdown. Django is the 50th percentile is 650 milliseconds. So 50% of the response times we're seeing that. 90th percentiles, 130 milliseconds. Performance degrades significantly in higher percentiles, indicating potential bottlenecks under heavy load. Wow. So if you have a heavy load, Django will struggle. At the 50th percentile, FastAPI is 100 milliseconds. Wow, very cool. FastAPI maintains much more consistent response times even at the 99th and 100th percentile. Conclusion: demonstrating better performance metrics, lower average and median response time, handles more requests per second, more consistent response times under load. So I mean, this is telling me to watch my queries, but I mean, I'm not doing anything major with the queries and serialization issues. Now Django, I know, is going to cache by default, so I would have expected it to perform a bit better. Consider scaling Django and horizontally optimizing its backend to handle it. Now I know Django, I'm using WSGI by the way. Now I know Django has an ASGI that I could use instead of WSGI, and I can then make it asynchronous. So I mean, so the FastAPI one, if you've not seen it, okay, sorry. So this is the Django view. Just for context, this is the Django view here that I'm using, and all I'm really doing is using a service serializer that pulls out a service and returns. And I'm assuming this would get cached anyway. So I'm a bit surprised by the results. Maybe you can add in the comments. Maybe I'm doing something wrong, but I can't see how this. I mean, what I'm trying to get at is I can't see what I could do short of going to an ASGI and making this asynchronous, which is what thing is doing. FastAPI by default is asynchronous anyway, but I'm even making the view asynchronous. And it's pretty much kind of doing the same thing. I'm pulling out the first service. Over there, I'm doing what? I'm pulling out the first service. I'm getting a service, which is kind of the same thing, pretty much the same test. So, yeah, I mean, FastAPI likely the better choice for high performance and high throughput scenarios. So you can see FastAPI is a better choice depending on if you're going to encounter huge traffic. I mean, I don't know if my test is something that would stand up in like a proper production database where the database is huge and there's multiple tables and all that kind of stuff. Mine is a basic test, but even here it seems to perform much better. Much better. I mean, it's just nuts. Where was that? Where did I see that? Yeah. Look at this. Handles 23,870 requests, no failures. That is just nuts. That is just crazy stuff. But yeah, I mean, so yeah, if I ever have to, if I ever have a project where I know it's a real-time sort of application and there's going to be huge loads, huge traffic, I'm definitely going to go for FastAPI. Now, FastAPI means you'd have to build everything from scratch, as in, like I said before, your views and your authentication and things like that, because it's a micro framework. So that's the downside of it. But the positives is the kind of performance you get, which is pretty cool. So yeah, I mean, I might see if I can leave my tests, that kind of the tests I did, and maybe people can comment or whatever. Just for context, both EC2 instances are in the same region, which was North Virginia. I'm in the UK, but I mean, that's a whole other conversation as to why I went North Virginia. I mean, anyway. So they're all in the same location. It's the same EC2 instance. Everything is same. So you can't sort of go, oh, one was closer to you and the one was in a different location, therefore that one is faster. Everything that I can think of is same. They're both using Postgres. Nothing different. Apart from the only thing I can think of, again, is my internet traffic. Let's maybe when I was making requests for the Django one, my internet slowed down or whatever. But even then, I mean, this is what, look at this, 22,873 requests with no failures. Django was 4,100 requests with no failures. Crazy. That is just crazy. Anyway, sorry, I just thought I'd make that video. Thanks for watching. Yeah, and I'll see you in the next one. Bye.